So a smart contract, you can basically think of it as like an if X then Y piece of code, essentially. And it started very simple on Bitcoin. You could consider that a very simple smart contract. You can transfer Bitcoin around, you can receive it, you can send it. It's a very simple contract. And it got a little more evolved on Bitcoin with like a multi-signature where you have multiple entities who have to sign off on a transaction. And, that you could think of that as a smart contract, but what most people refer to when they mean a smart contract is something like Ethereum, where it's a generalized smart contract, where it's written in code and you can write programmatic actions pretty much of how you define how users interact with this contract. So you can have like a decentralized exchange. If this contract receives a token, it'll give you a certain amount of a different token back. So it's not an application run by a server, some basement, Facebook or something, but instead it's an application that runs on a decentralized computer network, and that's the blockchain. And this blockchain hosts all of these different smart contract applications, and they're all, connecting to each other, allowing users to gain access to more permissionless applications that can't prevent you from interacting with them. So you can really think of it as like an application you use today on your computer, but it's one that runs on a decentralized network, meaning nobody can shut it down, nobody can prevent you from using it, and it's something that's going to be continuously running as long as that network continues to exist. So it's the new form of computation that we didn't really have before. I mean, we kind of went from like mainframes to personal computers to mobile phones. Now we have blockchains and distributed computing, and it's this entire new array of applications that, we've only scraped the tip of the iceberg of what smart contracts can actually do.
And smart contracts on Ethereum blockchain in its infancy, essentially stage, can be thought of as open APIs, right? However, the one downside to smart contracts, as what they are at right now, they cannot get information about the real world events because they can't send HTTP requests. However, there are ways to get around this using oracles. And this is essentially where the chain link comes in.
Right. Yeah. So with smart contracts, they are like isolated. They can talk to the same contracts on the same network, but because of the really strong security properties of the blockchain, it's purposely limited from external connections because that could be an attack vector for ruining the consensus of these transactions. So what you need is some entity to deliver that data on the behalf of the contract. And that entity is called an oracle. And originally we had centralized oracles like Oraclize. That was like a popular one for a while, where it's just a single server, a contract creates a request. The oracle sees that, fetches the data like the price of ETH against USD, and then returns it back to the contract. But the problem there is that you have a single oracle controlling your contract. That basically defeats the entire purpose of using a decentralized smart contract in the first place. If that oracle can just control your contract, like they could report that the price of ETH is $100 billion, that's going to cause some damage for a lot of contracts. So
and that's an example of what we've seen in centralized exchanges, such as Kraken, when Ethereum price just essentially went from, I believe, 1,400 to 700 in an instant, and they were essentially relying on just a single oracle, single feed, and it was centralized. And what you're saying is, whenever you do have this kind of centralized feed into a decentralized entity, such as smart contract, it defeats the decentralization purpose. And essentially, you only validate the input from one source. And that source can be manipulated, right? And that's the whole argument regarding the consensus and decentralization.
Right. It's basically a single point of failure. We're trying to get away from that. We're trying to get away from you need to trust a single entity. So really the solution is similar to a blockchain. You decentralize it. You have a bunch of different oracles and they all fetch this data for you. Then they aggregate it into one value and then submit that one value. So if a handful of nodes are corrupted or they're malicious or they're offline, contract keeps running, contract still keeps getting data. So that decentralization is crucial, and that's kind of what we saw with the release of Chainlink. Its mainnet in 2019 is these decentralized oracles, which the primary one, or the primary most common use of oracles, is price feeds for DeFi, because all that price data on centralized exchanges, decentralized exchanges, you need a single source, but that single source has to be a decentralized source, so it can actually become tamper resistant. So those price feeds are really the reason why we saw decentralized finance, DeFi, explode in adoption like we did, is because there were trustworthy oracles worth using. If we had centralized oracles, DeFi really wouldn't exist the way it is today.